will be the third time we are shooting a video on this wall. So, as I said in the last two videos, the system could be used for a lot of things. It's a multiple purpose system because this is a photovoltaic heater, which can be, which for short is PVT, as the short name for it. And yeah, so and it can be used for many applications. So this PVT, the use of PVT in Africa is Africa, that's in the tropics, such as Africa, Nigeria, and some other countries in the tropics, enables the simultaneous production of electricity and heat. Thereby, it makes it possible to achieve energy savings. For instance, in the handling of desiccant, it can be directly used by desiccant air handling units. The result of this system show that this system is a good supplement for electricity generation, and it also and it provides a thermal heat gains for drying, for heating, for cooling, and even industrial process heat. Such a system of this nature, from the results, is appropriate for application in dwellings, okay, office rooftops, and building facades, where you may where the surface area have limitations, and there is also demand for electricity, for both electricity and for either space heating or hot water. That's where you have demand for this hot water generation, electricity generation, and also space cooling. So PVT solar air heater such as this system could be used in every country, Nigeria inclusive, Africa inclusive, for agricultural production. You have agricultural applications such as industrial, such as cooling of offices in the farms, various farms, mechanized farming, production of hot water for treatments, hatching of eggs, brooding of chicks, and drying of crops, drying of leaves and fodder for animals like cows, pigs, goats, rabbits, snails, and so on. It could be used for industrial processing, for canning of agricultural byproducts, just as I said in the last two videos. I mean, its applications in agriculture will help boost any economy. Since maybe some economies could be predominantly mono economy, so the mass production of this kind of system, whether miniaturized or in large form like this, will help many applications, just as I have enumerated. Of course, other uses like the grid connections of this kind of system, grid connection of PVT of this kind of system could be used to generate sizable amount of electricity. Yes, sizable amount to supplement for some places have epileptic electricity supply and stuff. So its initial investment, its initial cost, investing on it is enormous. It's somewhat expensive, but it stands the test of time. That's the good part of this system. It stands the test of time because of that it has a potential for a lower life cycle unit energy cost than for separate PV, or for separate ST, that is solar thermal coupled system. Separate PV that is standing alone, and separate solar thermal that is standing alone. This is better than them. So two of them are coupled together and form this system. So it has a lower life cycle unit energy cost due to its multiple uses. So very great. You can see that we could get this electricity from inverter like this. You can see the inverter. You can get this electricity from this inverter. This is from the 240 volts. 240 volt mains inverter connected to the battery, which could be measured using this meter. This meter measures current, voltage, energy, power, frequency, and stuff. You can see the meter. You see the electricity generated. This inverter could be connected in parallel or series, as the case may be, and it generates higher energy. Though these inverters are smaller units, but you can also install powerful inverter higher. This is 1 kVA, 1 kVA. So these are about 4 kVA inverters here, 4,000 watt inverter, all joined together. They're all working. If you want, I test it for you. So we just connected one. You can connect all of them in series, in parallel, so that in order to boost electricity. So all of them are working, and there is a battery there. That is this battery there that charges by this PV. This battery here is being charged by this PV, okay, through the wires from the PV, but the wires connected directly to the battery, and the battery is also connected to this charge controller, so that the charge controller controls the charging. Okay. Then it's also connected to the inverter connected to the battery in order to produce its own electricity. Then some electricity could also be provided through the battery, if you like. Like this is a switch. This is a switch from the battery. Here, you can use it to charge phones. Then you can charge phones from the mains, from the extension there. As you can see, there is a light from the battery. We also connected it to this switch, but we realized that switch has a little bit. I think what burnt in the switch. I think what was it? What burnt? What
resistor?
I think the resistor burnt in the switch, which we are about to replace. So that was why we connected this directly to the battery. But you can connect. We made it such a way that you can connect directly through the switch, and so you can see electricity can be supplied from both ways. It can be supplied from the switch here. It gives this. You can also get it from the mains. Can I have your phone? Then we also could connect. We also could connect the phone through the phone charger. You have your phone charger.
It's charging.
So you can see the phone is charging now. It's charging. So the system has measurement devices that measure some parameters of the system, which we evaluated and found out that the system is good for all I have enumerated. All the uses I've enumerated. We use a temperature data logger. What the temperature data logger is about, I think I have it too. So one is being activated. So this is the one. This is another one, a customized one used for measuring temperatures. So we connect the flex run through the data logger, and it's being connected to this board. So you can remove this flexible wire from this board. You can put it, you can socket it. We built it in such a way that you can socket it and also make use of it. For instance, we put it this way. You can socket it this way. You can put it this way. You can see it has entered. So, and the temperature should be reading. Though this LCD is no more showing because I don't know, we exposed it to the sun and the sun got it damaged. It doesn't show again. So, but there is a place for memory card where we insert memory card, a place here, and we can get the readings through the memory card. For instance, let me demonstrate. So there is a place for memory card where you insert memory card here. Okay. So you can insert the memory card here. You can remove it this way. So insert the memory card and you take your reading, the temperature reading, and plot it using Excel files or any other method. So the system has aluminum. It has airflow through this system. The fan pumps the air. That is this air that is pumped by the fan. Though we can also make use of natural convection, but if you don't want to make use of natural convection, you can use forced convection. Here the airflow goes into the system and comes out as hot air. That's the thermal heat gain. It comes out as hot air, which can be used for drying of some stuffs, of some agricultural produce, tomatoes, leaves, and so on. So I can power the fan so that you see what the fan is made up of. So if we power the fan, the fan sends in air, and hot air is generated. So we can power the fan this way. This is the wire going to the fan. comes out here. Comes out here. So that's how the power with the fan, leave it, and it pumps the air, and the air comes out of air, which can be used for drying. So there are some of the instruments we can also use for measurement, such as this thermometer. You can see this is a hot afternoon, about after 11 to 12, and it's measuring 32.1. This one is 31.3. Of course, the one for ambient, I think we have the one for ambient. The ambient one is, where is that one of the ambient? Okay, let's assume, okay, let's take this to be for the ambient. Let's know the temperature of the ambient now. The temperature of the ambient should be let's determine the temperature of the ambient. The temperature of the ambient now should be okay. So ambient temperature now should be 33.1, 33.0. That's ambient temperature now, 33 degrees centigrade. That's the ambient temperature. So we use it to measure some system, and I mean maybe you can use it to measure the top of this place, and you can see what it can give you at the top here. If you leave it for some time, you can see it's rising. This is it's rising 33.6, 33.8, 34, 34.2. So you can see it has gone beyond ambient. This is about 34.5 now, but we are getting 33.0. This is 34.6. We are getting 33.0 degrees centigrade for ambient, but for the top of this, for PV panel, the top is giving us 34.9, 35.1, 35.2 is rising. So you can see that it's about 2 to 2.5 or 3 degrees centigrade difference, showing you that the meter is good. So we were using the meter to do some measure, some kind of temperature. Something happens here, measuring. We are also taking the measurement for airflow, inlet temperature, and outlet temperature of the air flow. So we measured the flow velocity of the airflow using an anemometer. There is this anemometer we use. I think, where do we keep it? So we use an anemometer for measurement of airflow through the fan, the airflow, the velocity of the fan and airflow through the system. We also measured the pressure of the airflow in the system using this pressure manometer. We also measured the insolation, that is the solar radiation, using this TES 133R data logging solar power meter. So we used it. So that was it. We also determined the relative humidity of this dryer using this humidity meter. So you can, as you can see, we also use this hand tech to measure voltage, current, power, and energy, and compare it with this meter, and they all gave the same result. Then we also dried some agricultural produce here. We dried some agricultural produce here. You can see we dried some agricultural produce here, and this is the remnant of what we dried. And so and we also troubleshoot. We also troubleshoot this from this laptop by using this cable. Of course, we have Arduino program we have in this laptop, and we use it to change the date and time and other things we need to change in this data logger. We use this laptop to troubleshoot by plugging in this cable. So that was how the system works. The system is being used by students for their research, such as this dryer here was used by a student. The system was also used for a PhD program. So it's a multi-purpose. It's a system that can be used for so many applications. So that's what the system was used for. Also, during my research, I also compared this system that the airflow in. The airflow inside this system helps in sustaining the life of this PV. It sustains the life of this PV. It makes the system viable. So I compared it with, of course, the one that is the ordinary PV system, and found out that this system performs better because of the airflow at the inside of the system. So thank you.